Greetings, math fans. All right, so this is day 4, and we're going to talk about really two different topics today. The first topic is called summation notation. Okay? And basically, let's kind of talk about what this symbol is. It's a nice little friendly Greek symbol. This is called sigma. Okay, it's a Greek letter. And the question I've asked you guys, I can't necessarily hear your answer, but what is sigma related to? Well, you guys should all know sigma is definitely related to sigpa because they're married. Sigma and sigpa. No, don't write that down. Okay, they're really not. And again, we don't even like to say sigma because sig sounds like cigarette, and ma is kind of sexist because you're talking about female. So sometimes I refer to this instead of a cigarette, what's healthy? Fruit is healthy. And you don't say ma, we call it person, fruit person. So we like to refer to that symbol as fruit person. Don't write that down either. Okay. Let me erase that, and we're going to actually talk about sigma. Okay? Sorry. All right. So sigma is sum. That's like the symbol for summation, sigma. And so we have a couple different things with sigma. One is we have on the bottom here, we say n equals 2, and this is our starting value. We start at 2, and we have a number on top, and that is our ending value. Okay? And then we have an expression, which is like n squared. So again, sigma is sum. Very, very important. So if I ask you guys to let's just kind of expand this. Let's just do this problem here. And so I'll actually ask you to expand. Expand means we're going to go from 2, so from this bottom number, to 4. So I have 2 squared, and then since it's summation, I'm adding those terms. So now I plug a 3 into there, plus 3 squared, and then plus 4 squared. Okay, so that's what it is. I expanded it. I wrote it all out. Let's actually calculate this out now. So 2 squared is 4, plus 3 squared 9, plus 4 squared is 16. If I add all those up, I get 29. So this means this is really expand when you actually write all the terms and write what each group is, 4, 9, and 16. And if I ask you to evaluate, which I would ask you to do both, that's evaluate. Evaluate is actually come up with my answer as 29. Okay? And let's look at the number of terms here first, math fans. Basically, do you see I have 3 terms here? I have the 4 and the 9 and the 16. Well, the way you get the number of terms, so terms is basically you're going to do the ending value minus the starting value, and then it's going to be plus 1. So if you look at it, of course we had 3 terms, so it's here, but let's look at it. It's 4, which is the top value, minus 2, which is the starting value. So 4 minus 2 is 2, and then we add 1 to that, and it's 3. So that's important. There are 3 terms here. Sometimes people look at it and they say between 4 and 2, and they go, oh, there are 2 terms because 4 minus 2 is 2. But if you count them, it's 2, 3, 4. There are 3 terms. Okay? So let's do a nice little friendly example here now. If I gave you guys summation n goes from 4 to 8 of 2n minus 3. That means I'm going to plug a 4 in, a 5, a 6, a 7, and an 8 into the problem. Okay? So if I do that, let's do it. I'm going to put it in bracket just to kind of separate each one. So it's 2 times 4 minus 3. Plus, now I'm going to put a 5 in there. So 2 times 5 minus 3. Plus 2 times 6 minus 3. Plus 2 times 7 minus 3. Plus 2 times 8 minus 3. Okay? So that's putting all the terms in there. If I simplify each one of these out here, it's 8 minus 3 is 5. and 10 minus 3 is 7, and 12 minus 3 is 9, and 14 minus 3 is 11, and 16 minus 3 is 13. So that's expanded. Okay, so this is expanded. And now if I want to evaluate, it's just add all the numbers up. And if I add all the numbers up, I get 45. Okay, that's not bad, right? Pretty easy. All right, so let's keep going here. And let's do another one. Evaluate. Sigma n goes from 2 to 15 of 2n minus 4. And you're like, ugh, it means I got to do 2 through 15. That's brutal. That's a lot. So I agree with you. And let's kind of take a look at just the first few terms, just for the heck of it. We already kind of looked at the other one that we've done. But if I look at the first few terms here, if I do 2 times 2 minus 4 plus 2 times 3 minus 4 plus 2 times 4 minus 4. Just look at the first few. Okay, I'll get, this first one is 0 plus 2 plus 4. What does that look like to you? Well, it looks like an arithmetic sequence, doesn't it? 0, 2, 4. If you look at the one we just did, right? You had 5 plus 7 plus 9 plus 11 plus 13, right? That was arithmetic as well. So the kind of nice thing about this is an arithmetic sequence. And what you want to do is, if it's an arithmetic sequence, so let's write this down. So arithmetic sequence, that means we know we have a nice little friendly formula here to figure out the sum of an arithmetic sequence. That's what this is. But we need a couple things. So let's write out what we need. So S sub n equals a sub 1 plus a sub n over 2 times n. So remember, a sub 1 is the first term. So we need the first term. A sub n is the last term. And n is the number of terms. Okay? So how do you figure out all of these? Well, if I figure out the first term is you plug the 2 in. Because that's our first term, right? So if I do that, plug it into the 2n minus 4. So it's 2 times 2 minus 4. Well, we already did that, right? That's equal to 0. That's our first term. Well, how do you get our last term? Well, our last term is plugging in the highest number, right? What it's going up to, the 15. You plug that into the equation. So it's 2 times 15 minus 4. So 30 minus 4 is 26. That's our last term. Right? Pretty easy. And then the number of terms, remember what I said to do. It's 15 minus 2. Always subtract, right? The top minus the bottom, which is 13. And then it's plus 1. So there are 14 terms. Okay? So I'm just going to kind of scoot this down here a little bit. And that's all we need. Now I can plug this in. So it's really S sub, and there are 14 terms. So S sub 14 equals a sub 1. And again, I'm not even going to think of it as a sub 1 and a sub n, because that actually gets confusing, because then you want to plug in a 1 into the equation. But really, a sub 1 is when n is 2. And a sub n, the last term, is when it's 15. All right? So that's important. You're looking at the sum, the top and the bottom number. So the first term is 0, and the last term is 26 divided by 2 times the number of terms, which is 14. And I multiply that out, I get 182. So that's a heck of a lot faster than having to go through this whole thing and type in 2 through 15 and add it all up and everything. Now you're like, well, is it really faster? Well, what if I say, instead of from 2 to 15, I say 2 to 150? Yeah, it's going to be a little bit faster. In fact, let's look at our next example. It's very exciting. So the next one is going to say evaluate. And notice, math fans, I'm not saying expand. Because if I said expand, that means you'd actually have to do a ton of work here, right? So evaluate, n goes from 5, and by the way, that n can be any variable. It doesn't matter. To 195 of negative 4n minus 3. We'll put that in parentheses, okay? All right, so The first thing I'm going to do is I'm going to find my first term. And the first term is plugging a 5 in there. Negative 4 times 5 minus 3. So it's negative 23. And then my last term is going to be negative 4 times 195 minus 3, which gives us negative 783. And the number of terms is easy. It's 195 minus 5, which is 190, but you got to add 1, so it's 191. Okay? So sum of 191 terms is the first term plus the second term, in this case is minus 783, divided by 2 times the number of terms. Okay, and if you do all that, you get S sub 191 is equal to negative 76,973. Not bad. So this is all these have been arithmetic. All right. Now we are going to do a geometric, just to kind of recognize it. And then we'll kind of review here a little bit in a second. Okay, so this one's going to say evaluate the sum. N goes from 3 to 12 of 3 times negative 2 to the n power. So just to kind of investigate this a little bit, because I know I already told you this is geometric. If I plug in a couple terms here, so if I do 3 times negative 2 cubed plus 3 times negative 2 to the 4th plus 3 times negative 2 to the 5th. So let's just take a look to show that it is geometric. If I multiply it out, I get negative 24 plus 48 minus 96. So how do I go from one to the other to the other? I actually multiplied by negative 2. Okay, and you can see that negative 24 times negative 2, positive 48 times negative 2, negative 96. So you definitely know if I divide, right? 48 divided by negative 24, negative 96 divided by 48, I get 2. So R equals negative 2. Okay, and it's important to kind of recognize what this look is, right? The other one was like, 4n plus 3. This one is negative 2 to the n power. It's to a power that makes it geometric because I'm multiplying it by negative 2. In fact, I know I did show all this work here, but see that negative 2 right there? That is our R value. Because it's multiplying, when n is 2 and 3 and 4 and 5, you multiply by negative 2 so many times. So R is negative 2. Okay, so we're going to use our nice little friendly formula. S sub n is equal to, well, I need a few terms here. Well, let me write it out first here. A sub 1 minus a sub 1 r to the n over 1 minus r. So obviously I need my first term. I don't need my last term, but I do need r, and I need n, which is the number of terms. Okay, obviously the first term, what do? You're plugging in that 3 again, right? You're plugging in the first number into the equation. And we already did that. That's the negative 24. R, we already said that's negative 2. And the number of terms, it's again 12 minus 3 equals 9 plus 1 is 10. Okay? So let's cursor down here a little bit. So really, S sub, there are 10 terms. S sub 10 is equal to A sub 1, which we said is negative 24, first term, minus, so be careful of parentheses here, right? Negative 24 times negative 2 to the 10th power over 1 minus a negative 2. Lots of parentheses, math fans. The top, or you can hit equals in the top, whatever you want to do. But if you type all that in your calculator, you get 8,184. Okay? So that's pretty easy. If you see a summation, you got to investigate it. So let's investigate, just to kind of review here a little bit. So this is a summary. The summary is if you see something like the summation 5n minus 6, you should know that is arithmetic. Okay, in fact, that 5 there, it's what your D value is. It goes up by 5. If I put a 1 in there, it's 5 times 1 is 5 minus 6 is -1, and I put a 2 in there. It's 10 minus 6 is 4, so it goes from -1 to 4 to 9, right? You're going up by 5s, so D is 5. Okay, anyway, that's arithmetic. If you see something like this, 4 times 3 to the n power, you should recognize that as geometric, and that R value is 3. Okay, because there's your 3 right there. And then if I see something like this, n squared minus 5n plus 1, that is actually neither, because you got an n squared, you got a 5, you got a lot of different things in there, so that's neither. So if I asked you for this one, you would have to manually expand and then evaluate. Now, am I going to give you anything like that that's from like 5 to 500,000? Of course not. Would I give you something like this and say n goes from 2 to 5? Yeah, that's reasonable, because you got to put a 2, a 3, a 4, and a 5 in there. Put 4 terms in there, right? Okay. So that's basically sigma notation. The next part of this lesson, math fans, is applications. Okay, so let's talk about that. Okay, I don't like to say word problems because kids all panic when you see applications. But basically, our applications, we're going to be working with money a lot for these applications. So basically, this is a general rule. You know how we learned it, a sub n is equal to a sub 1 r to the n minus 1? For money, we're going to be using r to the n and not to the n minus 1. The reason we're doing that is because if we refer to a sub 1 usually as our first term, well, a sub 1 kind of refers to the first year. So if I invest some money, how much is it worth after the first year? And it's not really a sub 1, it's really a sub 0. Right? That's how much money I'm investing after the first year. But that kind of messes our formula up. And we have a sub 1 as our initial amount that we're investing. So by compensating for that, we don't use n minus 1 now. We actually use n. And it's always for money. If we're talking about a sequence of numbers, if I said, 2, 4, 6, 8, 10, that is a sub 1. It's our first term. But again, with money, you got to start somewhere, and then the first year is actually you're earning interest on that first year's money. Okay? So this is a pretty general formula here. If it's working with money, it's to the n power. If it's anything else, like a sequence of numbers, then it's to the n minus 1. Very, very important. So remember, money is with just n. Anything else is with n minus 1. Okay? Very, very important. So let's do a couple problems here, given that. If you invest $100 in the bank, let's just say in the bank, and the interest rate is 5%. That's a good one. Right now it's like 0.5%. It's horrible. Okay, but let's just say it's worth 5%. My question is, what is it worth in 8 years? Right? So we need a couple things here. Again, let me write the formula on the side here. A sub n equals a sub 1 r to the n. Well, the a sub 1, of course, is $100. That's how much we're starting with. Okay? And r is our interest rate. Now, this is the only thing you need to do here. You don't want to put 5%, 0.05, because that would be like getting 5% back. If I put it as, let's just look at it. If I put it as 0.05, what that's going to do is that actually is going to say, well, I invest $100, and after 1 year, it's worth $5. So you're going to invest $100. You're going to go to the bank in a year and say, okay, I want all my money. They're going to say, here you go. Here's $5. And you're going to be like, well, that's the interest, but where's the rest of my money? Oh, so that's why we do, it's 1.05. You add, it's 1 plus the interest. Because this is like, that 1 is like your starting value. You get 100% of it back plus the interest. Okay, so just kind of be careful about it. So it's 1.05. And then we just plug it in. So it's a sub 8, 8 years, equals a sub 1, which is 100, times 1.05 to the 8th power. Okay, so a sub 8, plug it in your calculator, and you got $147.75. And guys, please round to the nearest cent. Okay, don't give me 147.7693 or $148. You round to the nearest cent. Okay? All right, so that's pretty easy. So that's an interest rate problem. Let's do a depreciation. It's very sad. Okay, so if you have a car depreciates, the other one was an appreciate. If you appreciate, you increase in value. If you depreciate, you go down in value. It's kind of like appreciate somebody, you're lifting them up, you're making them happier. If you're depreciating, then you're kind of depressing, right? You're kind of making them sadder. Yeah, good way of looking at it. So car depreciates 15% each year. The original cost is $25,000. What is the value after 5 years? Okay, so again, we're saying a sub n equals a sub 1 r to the n. We're using money, so it's to the n power. Because after year 0, it's still worth 25, and then the first year, it's 25,000 times some amount. Well, what amount is that? Well, obviously a sub 1 is 25,000. That's easy, right? And now r, instead of being, please don't use don't. I'm going to put don't does not equal 2.15. Because people do that, but that's like saying after the first year it's only worth 15% of its value. That's like horrible. All right? It's depreciating by, I'm taking away 15%. I'm not saying it's worth 15% of the value. I'm taking away 15%. So R, just like we did before where we said 1 plus the interest rate, it's 1 minus 0.15. So my R is 0.85. That's really important. So here we go. A sub 5 equals a sub 1, 25,000, times 0.85 to the 5th power. So a sub 5 is equal to $11,092.63. Okay? That kind of shows you how terrible of an investment a car is. If it goes down by 15% every year, it goes from $25,000, you lose about $14,000 of the car in 5 years. That's horrible, horrible investment. So what you want to do is you want to buy a used car where it's got like 1 or 2 years old and it's actually taken some of the depreciation out of that value of the car. All right, it's really important. Otherwise, it's brutal going down to $11,000 from a brand new car. Okay. Real quickly, I just want to show you if you would have used. Well, here this is just kind of important. So a sub n equals a sub 1r to the n. The reason we use this formula again, and I just really want to stress that as opposed to the n minus 1. Let's just say if n was 0, we just got $100. So if I said a sub 0, that means the value is $100 times, let's say the interest rate was 5% like before, so 1.05, and we just got the money, so it's 0. Don't you guys agree? What's anything to 0 power? 1. So this whole thing goes to 1, and I have $100. Well, of course I have $100. That's how much I started with. If you use the n minus 1, okay, that actually gets a little more complicated because you'd have 0 minus 1. It doesn't even really work, right? Because what do you have to the negative 1 power? Complicated. So that's why you want to use a sub 1. You want to use this guy and not minus 1. Really, really important with money. Okay? All right, my last example here, math fans, it's a good example. So you are given $50. Woo! Sweet. Thank you. You can double your money. You can double your money every year by investing it in Apple Computer. How many years will it take until you have $1 million? How many years? So basically, you're given $50. Every year, you're going to double money. So the first year, it's going to be, after 1 year, you're going to have $100, and then you're going to have $200, and then you're going to have $400, $800, $1,600, etc., etc. How long will it take until you have $1 million? So we're going to use our nice little friendly formula. A sub n equals a sub 1 r to the n. Remember, it's with money, it's to the n power. Well, you're basically saying I've got $50. So remember, that's your starting value. So 50 is a sub 1. A sub n is $1 million. That's how much I'm going to have at the end, right? And r, well, it's not really complicated. But if you're going to double your money, what's the interest rate? Well, isn't it 2? Doesn't 2 double your money? Or think of it this way. Remember how it's 1 plus like 0.05? Well, if I'm making 100% of my money, isn't 100% the same thing as 1.00, which is 2? Okay? And it's 2 to the n power. So I'm solving for n. How do you solve for n? Well, let's move this down a little bit. You, first of all, I have to divide by 50. So I get 2 to the n, and 1 million divided by 50 is 20,000. And how do you solve for that? You've got to take the log of both sides. Good old logs. Okay, remember that? And then this n goes in the front. And you get n log of 2 equals log of 20,000. And divide both sides by log of 2. So you get n is equal to, divide that out on your calculator, and you get 14.29. Now, remember, n's a natural number. Let's cursor down here. So this is supposed to be a natural number, which means 1, 2, 3, 4, 5, 6, up to whatever. If you said 14, if I rounded down and I said, how long will it take you to double your money? You told me 14 years. I would say you didn't quite double your money. You got to be 14.29 years. So how many years truly until you can double your money? Well, what you're going to do is you're going to round up. So round up to 15 years. Okay, so in 15 years, you're going to double your money. Okay, so kind of going back to the original problem, like if I said, well, I triple my money every year. 3, I quadruple my money every year. 4, so all depends on what you're talking about. That's what you put in there for R. Okay? So that's it, math fans. I said summation we learned about, and we did some applications. But again, when you're doing money, a sub n equals a sub 1 r to the n right here, math fans. That's what you're using for money. Okay? That's it, math fans. Have an outstanding day. Adios. Goodbye.